Good morning, good afternoon, good evening, wherever you are hearing me, wherever your time zone will be. You are welcome to today's class. We'll continue our lesson on vector differentiation. Then we'll move to another application area, the gradients. And so we have a lot to cover today. So once again, you are welcome. Let me quickly share my screen so that we proceed from there. I believe you can see my screen. I need a response, please.
We can see it, sir.
Okay, good. So let's move on. So we have today, let's look at the example. Another example for today. If A is equals to 5t squared I plus tj minus tk, t raised to power 3k, and B is equals to sine t
dubu biyu yake amma babu shi ma ya ƙare.
sine t sine t I minus cos tj. The question says find A d dt of A dot B, B d dt of A cross B, C d dt of A dot A. So, and solution now, let's look at it. Remember that we know the definition of d dt of A. We have d dt for A now. We have d dt of A dot B to be equals to A dot dB dt plus the A dt dot B. So we need to solve this one after the other. Let's look at the dA or dB dt first. Let's differentiate the B dt. What is the B dt? When you differentiate sine, what do you have? You have cos t dot I. When you differentiate cos, you have minus sine, which is plus sine t j. So let's look at the A now. We need to differentiate A too. The A dt is equals to what? So when you differentiate 5 t squared, what do you have? You have it to be 10 ti plus j minus 3 t squared k. So now let's call this one equation 1. What is equation 1 becomes now? Equation 1 becomes A we need to get our A. Our A says what? 5t squared I plus tj minus t cubed k dot the b dt, which is cos ti plus sin tj plus the a dt. The a dt is 10ti plus j minus 3t squared k dot b. Our b is what? Sin t I plus sin t I is minus now, minus cos j cos tj So this is what we have. So we need to do the dot products now for this one. So what do we have for the first one? This multiplied by this. That's the dot product. I dot I is I squared, which is equals to 1. So we don't have problem. We have 5t squared cos t. Then that is component to component. That is, look at what we are doing. This to this, j to j, then k to k. K, we don't have k. K in this case is 0. So plus 0k. So that is what we have. So that is what I'm doing now. So we have plus t sine t. You will not put any components there because you remember that I dot I is I squared, right? What is I squared, please? Anybody? Hello? Are we there now?
Minus 110.
Minus 1 squared. What happened to minus 1 squared?
Becomes 1.
Becomes 1. Is it absolute value? Anyone you put will be 1, will becomes 1. So let's take note of that. So we can proceed. So we have sine, t sine, then what happened to the last one? Remember, you have t raised to power 3, k, multiplied by 0. So everything will be 0. So we don't have k for that one. Then we said plus 10t multiplied by this will be 10t sine t. J multiplied by this, it will become what? Minus cos t. So is that the final answer? 3 multiplied by 0, k, will be nothing. So at the end of the day, we can add all the t together or all the cos together. We have 5t squared minus 1 minus 1 cos t. 5t squared minus 1 cos t plus, we have 10t here, 10t sin t, and plus this, it will become 11t sin t. Any question? There are ways you can solve it again. And you can also solve the same problem. Let's look at this. I can solve the same problem, the same
Hello,
if I
sir.
say, yes, go ahead.
Yeah, I didn't quite get because this minus cos t at the end of it. How do we do with that one, sir?
It's already matched together with this. Can you see it?
Yes, sir.
If I open this bracket with cos t, I have 5t squared multiplied by cos t, and then cos t again multiplied by minus 1, it will become
Got
minus
it.
t, cos t. Do you get it?
Got it, sir. Thank you very much, sir.
You're welcome.
Yes, sir.
Now, another point, another way of solving this problem is this. I can do A dot B alone. If I say A dot B, let's go to our A. Our A is here. If I said A dot B, what do I have? That is this multiplied by this. That is this multiplied by this multiplied by this. That's what I will have. This one will be 0 because there's nothing. Now, if I write it out, let's see how we're going to write it out. A dot B will give us 5t squared cos t, no, sorry, sin t, minus t cos t. That is A dot B. Now, I can now differentiate A dot B. Now, if I want to differentiate this, you have to be smart when you are differentiating this. It simply means you differentiate this one, you hold this one constant. You differentiate one, you hold one constant, like that, like that. That is what it happens. When I'm differentiating t, I will hold sin t constant. When I'm differentiating sin t, I will hold this one constant. That is the meaning. Have I make it clear to you? Do we
Yes,
agree?
sir.
So what is sin
Yes,
t when you want to differentiate sin t?
It will give you cos t.
Cos t. So that means I have 5t squared cos t. Remember, I'm holding 5t constant. Product rule.
Yes, sir.
Then I will now differentiate t and I'll hold sin t constant. What would it be?
Going to 10t. It's going to be 10t, sir.
Plus 10t sin t. Do you agree?
Yes, sir.
Now, we do the same thing to the other side. If I'm differentiating cos t now, let's say minus t, I hold t constant, differentiate cos t, what do you have?
Minus sin t.
Minus sin t, minus sin t.
Yes, sir.
So then I will now differentiate t and hold cos t constant. It will become minus cos t, because when you differentiate t, what do you have? 1.
Yes, sir.
So at the end of the day, I have 5t squared cos t plus 10t sin t minus times minus plus t
Plus.
sin t 1 multiplied by cos minus cos t. That's all. So we can write it the way we put the one up. All the t, all the cos, let it be together. If all the cos will be together, I have sin t, I have 5 squared minus 1 cos t plus 10t of 1t, 11t sin t. So it's still the same thing. Any question? Can we proceed? Can we proceed?
Yes, sir.
Okay, thank you. Okay, let's continue. That is A. We want to solve B. Our B. The B says we should d dt of A cross B. The definition is A cross the B dt plus the A over dt cross B. So what we need to do now is we already different. We have the A cross B. What is A cross B? How do we get A cross B? We have the B and the T. Let's go to the B. A. Let's first of all solve A. We have it this way. So we have A. Let's say in this case we have I, J, K. So what is A? Our A point, our A, somebody should read it for us. We have 5t squared. We have t and negative t raised to power 3. That is from equation A. Then we don't need, I just put this one there. I need to do this one, the B dt, when we differentiated it. Let's check it, it's there. We have cos t, sin t, we have 0. The sign here is saying plus. So don't forget, plus I, J, K. So what is the A? Remember, the A is the first one that came forth, right? What is the A in this case? The A is 10t, 1 minus 3t squared. What is B? Sin t minus cos t, 0. So you first of all find the determinant of the first part and get the determinant of second part and add both of them together. That is what the question asks you to do. When you see a question like this on that day, this is what they ask you to do. Anytime they said cross means you find the using determinant theorem, to be able to solve it. So I can go ahead and solve this problem now. So in this case, let's deal with this one first. That has plus, minus, plus. Remember what I told you the last class. When I'm solving I, the entire I column will be parallelized and the row of I will be parallelized. That means this place will be parallelized, then this also will parallelize. So I will left with this. So I have this multiplied by this multiplied by this. So it simply means I have, let me just take my time and do that. T multiplied by 0 minus t cubed multiplied by sine t. Are you following it? Then I can release this one now. Then the next value, this is positive, this is negative, negative will follow here. Then I'll pick J. The column of J will be parallelized also. The row will still parallelized. So it simply means I have 5t squared multiplied by 0 minus t cubed multiplied by cos t. The last column also, which is positive, will also parallelize, and the first row will parallelize. We release this one, this will be affected. So we have 5t squared multiplied by sine t minus t multiplied by cos t. So let's take note of that. So in this case now, we can just quickly solve this one before we add the other one. Or you can add the other one so that you won't get lost. Let's do the same thing. Let's add plus, let me use another sign, another color here, plus. So my positive minus positive. You pick this one, this column, this row would parallelize, the column will parallelize. So I have 1 multiplied by 0 minus 3t squared multiplied by minus cos t. Finish this one. Minus, open the brackets. We release this one. We deal with this one. So it simply means that you have 10t multiplied by 0 minus 3t squared multiplied by sine t plus, we are dealing with k now. We cancel this one parallelized. So we remain what? 10t multiplied by negative cos t minus 1 multiplied by sine t. Any question? So we can now analyze it one after the other. You have to be careful in this case. So let me pick this one. Let me do it face by face. This is 0. This is minus times minus, positive. We have t cubed sine t. So let's say we finish this one. Don't let me use this. Minus, this is 0, positive t cubed cos t. This is positive. So you have it to be 5t squared sine t minus t cos t. So we now have positive. Let's do the same thing here. 0 plus, this is, you have minus times minus, positive. So minus is still outside. We put minus 3 squared cos t minus, this is 0. This is positive 3 squared sine t. Plus, now this is supposed to be minus times this. Let's deal with what is inside first. Minus 10t cos t minus, this is minus sine t. Any question? So you need to be legible that day when you are solving this problem. You have to be careful, but don't forget, we omitted something which is very crucial, and I was expecting you to talk about it. Here is supposed to be I. Our component must follow J, and don't forget this one is K. Our component must follow, and this is also I, J, and K. Component must follow. This is I, J, K. This is I, J, and K. So because we are going to use the same component to be able to add up, to do the adding up together. So the first one, if I want to write it out now, you agree with me, I can say I have 3 sine ti. The second one will be minus 3 cubed cos tj. Then the last one will be plus 5t squared sine t minus t cos t k plus negative 3t squared cos ti minus 3t squared sine tj plus minus 10t cos t minus sine t k. So we can go ahead and add each of the components to one another. So when you see a question like this and they put 20 marks, be careful. You have to take your time and solve it. Don't just jump into it and say you just do anything or anyhow on it. Please, you find yourself to be blamed. You have to take your time and solve it neatly. So we can add this one together. This and this can go together. That is, this component can follow. This also can follow. And this also can follow. So if you are adding the two together, what do we have here? We have t cubed sine t minus 3t squared cos t. I. Everything is I. Now, for j, minus is common to them. We can take minus out.
Sir, it's not playing on my screen, sir. I can only hear the voice.
It's because of your network. Others, can we see my screen, please?
Yes, sir.
So it's your network, please. Just shift your base a bit and get a good spot. Wait, it's because of the network. J. So we have t cubed cos t plus 3t squared sine t, all with component of j. Then the last one, we need to add this together. But in adding them together, you have to be careful. Let's say plus. Remember, there is a t square here, there's no t square. So the one of things, you can't add t square, just add it. Just write anything t square separately. Now, let's now see how we can do the rest. I have minus t here, I have minus 10 here, which is cos. It'll be minus 11 t cos t, then minus sine t. Please don't add this sine t plus this. It doesn't take, they are not the same because this one contains square and this is ordinary t. You don't have the component of t squared here, the other side. So I can say that I have my final answer. Any question? Silence means no question. Okay, let's proceed. Ifegbelero, are you there? Ifegbelero, are you there? Uzain?
Yes, sir.
Oh,
I'm
okay.
with you, sir.
Okay. Samuel, Joshua, Babatunde.
Joshua, I'm here, sir.
Okay. John, are you there? Okay, let's continue. I hope it's making sense. Now let's look at the C. The C says d dt of A dot A d dt of a dot a. It simply means the definition says a dot dA over dt plus dA over dt dot a is the same thing as 2a dot dA over dt, because we have the same differential equation. So we have power to do that. So now let's first of all look at what is 2. The 2a will be 5t squared I, don't forget, plus tj minus t3k dot, what's the differential equation of the a dt is up, we did that, 10ti plus j minus 3t squared k. So in this case now, I can open the brackets by saying I have 10t squared I plus 2tj minus 23k dot 10ti plus j minus 3t squared k. Remember the a dt, you've already defined the derivative of it. So you can now find the dot of what you have here. You have dot that dot, you have 100 t cubed plus 2t dot 1 dot j, you have 2t, you have plus 2t, negative 2t dot negative 3t, 6 t raised to power 5. Any question? So how I'm just doing one example or the other so that when you are faced with different questions, all you need is just the method of solving the problem. Once you have the method of solving the problem, you can solve it.
Meeting from the analytical vector from the ijk, then about
You said, Samuel. You said what?
The vector components are missing from the.
They are not missing. Okay. The components are not missing. Remember, that is why I remind you the other time, I dot I is what? Is 1.
Yes, I get it.
So anytime you dot this, I dot I is 1. Then 1 multiplied by 100t cube is 100t cube. Anytime you see dots, definitely you won't get any component. But look at this. When we are doing cross, you will still have your component back. Can you get the difference now? Okay, let's look at this question, number 2. If A is equals to 2s squared y minus s4 I plus exponential s raised to power y minus y sine x j plus s squared cos y k. find the following, please. Find Roman figure 1, the A, the X. Roman figure 2, the A, the Y. Roman figure 3, the square A, the S squared. Roman figure 4, the square A, the Y squared. Roman figure 5, the square A, the X, the Y. Roman figure 6, the square A, the Y, the X. Okay, let's quickly solve this one. Solution number 1. Now, how do we solve this one? You have our dA, the X. It simply means d dx of 2x squared y minus x raised to the power 4 I plus d dx of exponential x minus y sine x j plus d dx x squared plus y k. So all you need to do is differentiate with respect to x. Remember from your calculus knowledge, that is what we are working on now. So if I want to differentiate this now with respect to y, with respect to x, all the y will be constant, right? So let's differentiate it. What do we have? Anybody? Yes, please.
4xy
4xy. Thank you, Joshua. 4xy
minus 4x3 cube.
X raised to power 3 I. Thank you. Plus, how do we differentiate this?
Okay.
Anybody?
Minus E. Minus E.
No, there's no negative. Now, let me quickly give you this. The int to undo differential, let me just do it separate here. I will clean it. If you want to write it, quickly write it. It simply means d dy. Are we differentiating with y or x? The x now.
X.
That's the meaning. So if I differentiate with respect to x now, what do I have? I will have, when you differentiate x in this case, x will be 1. 1 multiplied by y exponential xy. Do you agree with me? Hello?
I
Do we agree?
is yet to sink in.
Don't worry, just write it down. It will be sick. It will stop very soon. It's better you do. Go and check the way you did. Okay, now if you have exponential 2xy, it's still the same thing. Or let's say exponential 2x. Okay, let's say exponential 2x. Differentiate this one. It's the same thing. This is your y. Differentiate it. The y, the x will be what? You bring everything here, and this one still remain the same. Remember exponential system. Then differentiate this one with respect to x. You have 2 exponential 2x. Do you agree? It's still the same method we're using. Okay, let's proceed. Don't worry. Let's continue with this. So when you differentiate this one now, what do we have? We have y exponential xy. Now, we need to differentiate sign. What do we have? Y
Cos.
cos,
X.
yes, cos x, everything G, plus K. You have 3 what? 2 S cos Y K. So that is what they asked you to solve. So now, let's do the one of Y and see what we are going to get. That is Roman figure 1. Roman figure 2. We have the A dy is the same thing as d dy into 2x squared y minus x4 I plus dy into exponential xy minus y sine x plus d dy x squared cos y k. So let's differentiate this with respect to y now. What do you have? Anybody?
This becomes 2s squared. 2s
Yes,
squared.
2s squared. Thank you. I. Because everything here returns to what? 0. Then plus, differentiate this one with respect to y. What do you have? Do you agree with me?
Yes, sir. Yes, sir. That's the opposite.
So when you differentiate this, what do you have?
Minus sine y.
Thank
X
you.
squared minus sine.
No, we know
So that
what.
settles it.
Yeah.
So number 3 says what? The square y over the x squared. What does that mean? Remember that we know it simply means, let me break this one down. It simply means the x into the a dx. Do you agree with me?
Yes, sir.
Aha. Now that you believe, it's the same thing we are going to use. We know this. No, we have this one in question 1. So it will be the same thing that you will do to differentiate again. So it's going to be d dx of the first one, which is 4xy minus 4x cubed, I plus d dx of y exponential x minus y cos xj, then d dx of what? 2s cos y k. So you have this one. So let's differentiate this one with respect to x. What do we have? 4y minus 12x squared. I plus, now differentiate this one. What do you have now again? Who can tell us?
Y squared exponential xy.
Thank you. Y squared exponential xy. So if you differentiate this one with respect to x, what do you have?
Plus y sine x.
Plus y sine x. Thank you. J. Then When you differentiate the next one, what do you have? That settles the matter. That's the answer. So it's not that hard when you know what you are doing. I believe we can do the y. Can we quickly do y? The square. Let's do it. The square a dy squared. It's very simple. D dy of the a dy. So we go to the y, where we have d dy into 2x squared I plus d dy of x exponential xy minus sine x d minus x squared d dy of x squared sine y. Okay. So if you want to write this one now, what do we have here? The first one will be 0i plus, when you differentiate this one, you have x squared exponential x y. This is 0 minus when you differentiate sine y, what do you have? X squared plus y k. So that is just the analysis. How many of us got the same thing? What I did. So let's look at it. We have d squared a dx dy. How do we handle this? It's the same thing as d dx of the a dy. So you can see d dx, the a, the y. So we can proceed by solving it. We know the a, the y. So since I know the a, the y, I can substitute. I can solve this one by saying d dx. The a dy is all, which is same thing as 2x squared I plus d dx. You have x exponential xy minus sine x j. Then minus d dx into x squared sine y k. I can solve this one by saying, if I solve this one, what do I have here? I have 4x I. Then if you want to solve this one with respect to x, what do you have? Plus xy exponential xy. Now, you have to be careful in this case. Remember, this case now has turned to product rule. Because you have x separately, you also have exponential separately that contain x. So you differentiate exponential first, or you differentiate x first. I'm differentiating exponential first. So I will have xy exponential x. I hope you are getting it. So here with our plus, if I now differentiate x now, this will be exponential xy. Now, I need to differentiate x, sine x. What do I get? I will have cos x. Okay. Then let's differentiate this one with respect to x2. minus 2x sine y k. Any question? So if they ask you also to do the same thing, number 6, which I believe you can do, the square a, the x, the y, is the same thing as the square a, the y, the x. That is, the order of differential is immaterial in this case. You are still going to have the same thing. That is, the order of differentiation is immaterial. Any question, please? Are we tired?
No, sir.
We still have a lot to do. I don't know how we're going to do it. Please, when it's your exam, because I can see some drafts, first draft or second draft or whatever, online. Number 3, let's look at this.
We are having mathematics on the 12th of next month.
On the 12th.
Yes, sir.
Wow. Okay. X, Y, Z equals to xy squared z. And A is equals to x z I minus xy squared j plus y z squared k. So we're asked to find the cube.
Is that it? Looks like if
Sorry, sir. If what is the bracket?
This is phi, they call it phi.
Okay.
If phi x comma y comma z equals to x y squared z.
okay, and okay.
A and A equals to xz minus xy squared plus yz squared. Find the following. Are we there? Can I continue?
You can continue, sir.
Okay, solution. Now let's look at this. If you're given this, I know some of you have seen this question before or similar. Please mute yourself once you are not talking. You've seen something similar before, and it makes sense now when you solve this problem. So for us to solve this problem, there are certain things you need to consider. One of it is we need to define phi A first before you differentiate the phi A, because we only have here A and phi. Our phi is three planes. We have X, Y, Z. So for us to get it, we have it to be, let's bring phi in. Our phi is XY squared Z multiplied by XZI minus XY squared J plus YZ squared K. So what is going to be everything here multiplied by this, everything here multiplied by this, everything here multiplied by everything here. So that is what we are doing. Remember that your phi does not contain any component. There's no high JK. It's just like a arbitrary, let's say, constant. You are using it to open the brackets. So now XY squared multiplied by this, it will be X squared, Y squared, Z squared, I, minus S squared, Y raised to power 4, and Z raised to power ZG, plus X, Y raised to power 3, Z raised to power 3. Okay. So, any question on this? Hello? Any question? I need a response.
No questions, sir.
Go
Okay.
ahead, sir.
Okay, good. Now, remember the question says we should solve the cube, the S squared, the Z. You need to be careful. So let's start with this. For us to do this, you need to do this, the X, or the Z rather, of phi A. It will lead you to the X, the Z, the X, the Z, of the same phi A. And it will not, by that time, this one has turned to 2. It will now lead us to the S squared, the Z, this one turns to 3, the phi A. So these are the things we want to do now. So let's start from the beginning. So we have D, the Z. Of phi A. So we know the definition of phi A. We are differentiating phi A with respect to Z now. So what's going to be the first one? Anybody? Let's say D, the X, let me write it. S squared, Y squared, Z squared, I, minus S squared, Y4, ZJ, plus XY cube, Z cube, K, which is equals to, let's differentiate this one now. Thank you. So the answer will be what? 2. The first one will be what? 2x squared, y squared, z, I, minus x squared, y4, j, plus 3x, y3, z squared, k. So that is the first answer. So we need to do, the next one will be, according to our arrow, d square a phi over the x dz. So which is going to be d dx of the phi a over the z. In your own case, it might not be phi, it might not be phi a, it might not be z. You have to read the question line by line before you answer it. So in this case now, I have d dx of 2x squared y squared z I minus s squared y4 j plus 3xy cubed z squared k. So it's going to be what? So this is what will be what? Let's differentiate this with respect to x. 4x y squared z I minus 2x y4 j plus 3y cubed z squared k. Any question? Then we can now proceed by doing this cube of phi a, the s squared, the z will be I can't hear what you are trying to say, please. Hussein. Probably you can type what you want to say, please. So we'll differentiate this one will be 4y squared z I minus 2y4 j plus 0k, because we don't have x at all. So at the end of the day, we have the cube of phi a, the s squared, the z to be equals to 4y squared z I minus 2y4j plus 0k. So now that we have this, that's not the final. Remember, there is a boundary here. We are given the boundary. It said 2. They said, find this at the point 2 minus 1 and 1. 2 minus 1 and 1. So for us to do that, we need to represent it here. Now said at point x equals to 2, y equals, yes, in fine.
Okay, sir, sorry, sir. Why do we have to differentiate it and differentiate x twice, sir? I think the first one was 4xy square rather. And we
Yes.
have to differentiate again. I don't understand that side.
And that's the question. The question says, look at the question here. Find the cube of phi a, that is the x squared, the z. Hello?
I understand answer. Yes, should be
Okay.
twice.
Please read the question. I know you are used to just 1 point, but now in this case it's different. So it simply means on our equation, we have to, from here, we substitute for what is y? Y is -1 squared. Z is what? 1 dot I minus 2 into -1 raised to power 4 J plus 0 K. So at the end of the day, we have what? 4 into 1 multiplied by 1 I minus 2 into 1 J plus 0 K. So you have 4I minus 2D. That's the final answer. If you stop here, you have half mark. So you need to complete it with a point. Remember, it's a pen on paper. Any question? Any question, please? Silence means no question. But on the number today is supposed to be for this topic, the factor differentiation, the factor differential operator del. And del is represented by this. And we can define it in this way to be this is equivalent to, anytime you see this del, is equivalent to d dxi plus d dj dyj plus d dk.
I think so.
Which is
Hello,
same
sir.
thing. Yes, go ahead.
Please, with your permissions, I want to go and pray and come back, sir.
No. You don't need to do that. You don't need to ask for my permission. You are free to do whatever you like. All you need to do, you don't need to tell us you are doing that. Is that okay? It's a free word.
Okay.
All you need to do is you can mute yourself and do whatever you want to do, or you can excuse yourself. It's fine.
Thank you, sir.
You're welcome. So we have d dx plus j d dy plus k d dz. So, and these are the definitions. And the factor operator possesses properties analogous to those ordinary factor. It is useful in defining three quantity which arise in practical application, and is also known as the gradient, the divergence, and the curve. When I said the gradient, that is, these are the things we use in the practicals. Number one, we know the del to be, will be useful for the gradients. So these are the topics we are going to solve. The divergence, and the curve. So you will see questions, they'll be asking you, what's the divergence of these? What is this? And so on. On the divergence, let me pick number one, that's a divergence. Sorry, on gradient rather. For the gradients, we said in this way, let's phi equal phi of x, comma y, comma z be defined and differentiable at each point. At each point x, comma y, comma z. In a certain region of space. That is, our phi defines a differentiable scalar field. Differentiable scalar field. Then comma, the gradient of phi written in this way, or they call it grad phi, is defined by this equals to d dx I plus d dy j plus d dz k multiplied by this. So at the end of the day, you have d phi the xi plus the phi the yj plus the phi the zk. Note that del phi defines a vector field. Note that del phi defines a vector field. Then it can also be multiplied by what we call by a direction. Okay, let me ask us a question. Let me stop sharing, please. Okay, guys, on a quick one, is it possible for us to